When we talk about solubility, we have to also talk about, talk about solutions, we also have to talk about solubility. And solubility is how much of our solute will dissolve in the amount of solvent that you have. So solubility is the amount of solute that dissolves in a given amount of solvent. And it's usually reported per 100 milliliters. So grams per 100 milliliters. How many grams will dissolve in 100 milliliters of your solvent? A saturated solution contains the maximum number of grams of solute that you can put in that amount of solvent. An unsaturated solution contains less than the maximum, so you can still add more and it will still dissolve. So in solubility with compounds, the chemists always say like dissolves like. So if it's ionic or polar covalent, it's going to dissolve in a polar solvent. And the universal polar solvent is water. Okay, so if it's an ionic, like salt, or if it is a polar material, then it will dissolve in water because it's also polar. Also, neutral molecules with an oxygen or a nitrogen atom, if they can hydrogen bond, they're going to be water soluble. That's why your alcohols are usually water soluble, at least the small ones, because they have the ability to form this hydrogen bond between the hydrogen of the water and the much more electronegative oxygen of, oxygen of the alcohol. So that's why you can mix the alcohol in your drink, in your cocktail, and it will dissolve. Nonpolar compounds are going to be then soluble in nonpolar solvents because like dissolves like. So our organic things are things with carbons and hydrogens, oh my, that don't have oxygen or nitrogen or fluorine or anything like that, or that are symmetrical, are going to dissolve only in nonpolar solvents because they only have London dispersion forces. So octane, which is only composed of C8H18, will dissolve in carbon tetrachloride because they are both nonpolar liquids. And since they both have just London dispersion forces, they can London disperse with each other. When solvation, okay, and that means when something is soluble or dilutes or lets it, the solvent then surrounds the solute molecules and dissolves. When solvation releases more energy than it's required to separate them, then it's going to be exothermic, releasing heat. If the separation of the particles requires more energy than is released, then the process is endothermic and it's going to be heat absorbing. So general rules for solubility of ionic compounds. Why is this important? Well, there's a rule about things that you can mix in a syringe. And one of those reasons is because some things are not soluble in others. And if you mix them in a syringe, you're going to put two liquids in there and you're going to end up with a solid in your syringe. And you're not going to be injecting that solid into a patient. So in rule one is a compound is soluble if it contains one of these following cations: lithium, sodium, potassium, rubidium, and cesium. Okay, and those, if you look at your periodic table, those are all group 1A. If it contains an ammonium ion in it, then it's also going to be soluble, but not necessarily a great thing to put into a patient, right? Rule 2. A compound is soluble if it contains one of the following anions: chloride, bromide, iodide, unless it's mixed with a heavy metal such as silver, mercury, or lead, which we don't want to put in anybody anyway. Nitrate is soluble. An acetate, which is the ion part of acetic acid. Sulfate, except if you're going to put it with, that should be a 4. sulfate except for salts of barium, mercury, and lead. Notice mercury and lead are not going to be soluble hardly ever. Okay, and so those that you would always avoid, anyway. But barium also is not soluble with sulfates. So for most ionic and molecular solids, solubility is going to increase as temperature increases. If you dissolve a solid in a solvent at a high temperature and then you slowly allow it to cool, you can produce what's called a supersaturated solution. And a supersaturated solution has more than the maximum that solvent should have of solute. So if you dissolve it by heating it up really hot and then slowly cooling it down and not hitting it with your leg or anything, you can supersaturate the solution. Supersaturated solutions are pretty unstable because usually if you just like tap them or something, then you're going to get a solid form. The solubility of gases, though, decreases with increased temperature, because if you think about it, if you've got a gas in something, okay, and then you heat it up, those are going to be bouncing and they're going to be leaving your pot faster, right? So they're not going to stay in the liquid, they're going to want to get out of there. And so it's the opposite of a liquid, because in a liquid you're going to, if you heat it up, you can put more solid in the liquid form. Okay? So one thing, and we're kind of going to go retro back to gas laws here a little bit. One reason that we look at this is because of how temperature and pressure can affect solubility. Henry's law is a gas law, but it's kind of like a liquid and a gas law. It states that the solubility of a gas in a liquid is proportional to the partial pressure of the gas above the liquid. All right, and we talked about vapor pressure a little bit, right? And so that's how much pressure is above it. So the higher the pressure, the higher the solubility of a gas is in a solvent. So if I have a closed soda can, a short soda can, and it's closed, and I have carbon dioxide in a liquid, okay? That's what gives it its fizz. And so if I open that, what's going to happen? The first thing you notice is, poosh, right? And so that sound you hear is that all the gas that was in the head space of that comes out first. What you've done is you have lowered the pressure in this can by opening it up. So now all the CO2 molecules that were pushed into the liquid are going to start to try to come out of the liquid. And so by releasing the pressure, you have lowered the solubility of the carbon dioxide in the liquid. When it was closed, we were putting pressure on them, and so they would stay in the liquid, okay, and they would stay in there very happily. But as soon as you release that pressure, they're going to try to go out of the liquid to be a gas again.